Hi everyone, my name is Michael Wittman. I am the chairman of the board of Blue Sky Biochar. I want to thank my host, Matt Powers, my dear friend, for inviting me to be a part of this program. What we're going to do today is we're going to talk about biochar. What is biochar? Where did it come from? How is it made? And all the potential uses for biochar across the board. Biochar has many different uses. So to start off, let's talk a little about what biochar is. Biochar is charcoal suitable for soil. It's a fully carbonized charcoal. Unlike certain charcoals which are not fully carbonized, meaning that there's still some organic material in them, we don't consider that to be biochar. The word biochar is short for biological charcoal. So it's basically carbon, charcoal, biochar. It's number 6 on the periodic table of elements. And this here is an example of a carbon molecule. This is a buckyball, those of you know who Buckminster Fuller is. This is also known as fullerene. It's a unique carbon structure. It's 5 carbon molecules in sequence in this circular form. I also have one around my neck, which I wear regularly. Buckminster Fuller was an amazing person. If you don't know about him, I recommend you look him up. When the first plants started growing on firm land on planet Earth, the fires created by lightning that lit these plants and trees up and left the ash and char behind was the beginning of how biochar came to be in our modern day. So what is biochar? It is a management system of soil. Biochar manages our water, holding 7 times its weight, so it helps to drought tolerate. Biochar holds nutrients like a little bank, and it prevents runoff of those nutrients by up to 80%. Biochar also has a carbon structure that is so porous that it creates all this little cavities within the structure of the carbon or the biochar. And each one of these little cavities are luxury condominiums for microbiology. So it helps microbiology to proliferate, expand their colonies, and enrich the soil to a very high degree. Biochar is also carbon negative 3:1. Now what we mean by that is, simply put, for every pound of biochar we put into the ground, we are sequestered 3 pounds of carbon gases from going into the atmosphere. This is the scientific research which has been well proven. Now, when we talk about carbon negative 3:1, that is what biochar is when we put it into the ground. We make it and put it into the ground. However, you can go further carbon negative if you factor in the fact that it's going to reduce the amount of water needed, and that lowers your carbon footprint. Reduce the amount of fertilizer needed, that reduces the carbon footprint, and expands the colonies of microbiology in the soil, which builds the carbon in the soil, and the soil itself starts to become a carbon sink as well. So you can actually go beyond 3:1 negative. What those numbers are variable and not necessarily so researched, but there's no question about it that when you use biochar with proper protocol, you're going to have a very low carbon footprint in your garden, on your farm, or in any other use that you're going to use it for. Another really interesting fact about biochar is a fixed carbon. This is not a fertilizer. It's just a structure to manage the soil. And it is a fixed carbon. And a fixed carbon in the form of this charcoal has a lifespan of many centuries. So it is a permanent amendment. Doesn't mean that once you put it in, you don't want to add more, but whatever you add to your soil is going to be there for many centuries. So it's more of a capital investment into your soil than a yearly expenditure as other inputs would be. Nature started using it, as we said earlier, about 500 million years ago. And humans, as we know, started using biochar about 8,000 years ago. We know this through carbon dating. However, we don't know much about the people who did it back then. What we do know about, and many of you have heard of the terra preta de Indio, the dark soil indigenous from the Amazon region of Brazil. That particular culture took biochar to a very high level. About 2,500 to 3,000 years ago, the indigenous peoples of Brazil, the Amazon rainforest, discovered biochar kind of accidentally. From what we know, they were using communal fire pits. And in these communal fire pits, as the charcoal built up, they excavated it out, threw it aside, and continued to do their cooking. When they first started doing this, they had a population in this region of about 150,000 people. Within a 1,500-year period of doing this, they built their population up to 2.5 million people because they were able to produce enough quality food and enough abundance of food to expand their population. Now, those of you who don't know, the rainforest has amongst the most desolate and degraded soil in the world. It has about 6 to 8 inches of very fertile soil on the top where all the organic matter is, but down below it's pretty barren due to all that rain washing all the nutrients and washing all the microbiology away. So as they used it, the char built up and worked its way down into the soil column, and at the peak of their existence, it went down over 2 meters down into the ground. In about 1546, they were at the peak of this. Huge population, incredible buildings, 2-story buildings for 14 miles up the river. And at that point, a Spanish explorer named Ariana came down the river and discovered them. He was sent by Spain to discover gold. I guess he didn't realize he discovered black gold. So he was really blown away by the abundance of people and food and the agricultural society that they had built up. So in his journals, his maps, and his charts, he wrote down everything that he saw. And he said to his crew, when we go back to Spain, we're going to be heroes for discovering this. Well, of course, that's not exactly what happened. Nobody back home believed him. It took 60 years for Spain to finally send other explorers back to that area using Ariana's maps, charts, and journals. And when they got there, 60 years after he had left, no one was there. Everyone died from smallpox, influenza, measles, and syphilis. That's the gift he brought to them. Over a period of about 10 years, we noticed, what we found was that everybody had died, and nature basically dissolved all the buildings, covered up all the evidence of what they had done, and it was basically lost for about a 400-year period. In the beginning of the 20th century, the invention of the airplane, as people flew over this region and they looked down and they said, wow, why is that area so rich and that area not? Well, at that point, scientists descended upon the area. All types of different scientists, archaeologists, anthropologists, biologists. And when they first got there, they said to themselves, well, I don't know why we're here because there's no way humans did this. Nature must have done it. But as soon as they dug into the ground, they found the evidence. Pottery shards, bone fragments, shell fragments, and other evidence that humans did this and did it for a purposeful reason. All over the world, other indigenous peoples, other cultures also discovered charcoal as an aid to building their soil's fertility. It's just that the Amazonian region did it to the highest level. So this was something that was being adopted all over the world. It wasn't just the Amazon region. And as this practice grew, people were able to grow more food and build their populations and make a better life for their communities. Biochar is also being used in hempcrete. Here is a hempcrete block with biochar in it. I'm working with a company right now that is adding biochar to their hempcrete, and they're finding fantastic results. It actually helps to structure this a little bit better. It's great for insulation. It's also great for keeping molds and mildews and other kind of fungal things from proliferating in hempcrete, which could happen. So over the years, I have made biochar out of everything I can possibly find. Here is an example of olive pits that I made biochar from. Here's another one that I made out of avocado pits. I turned them, let them dry out, and made biochar from the avocado pits. And these are just samples from my research that I've been doing. I've done it with pistachio shells. I've done it with just about everything. Here's something interesting. Here's an old wooden sake box that was leaking, and I carbonized it. It's really lightweight. When you char wood or char biomass, you lose about 2/3 of its weight. So it weighs about 1/3. Once you create a biochar added living soil, biochar being the key component in living soil, you're going to have something that's regenerative and gets better and better and better over time. We know this because the Amazonians, over that period of time, their soil kept getting better and better. We call it terra preta de indio, the dark soil of the indigenous. That soil, all these thousands of years later, is still doing its thing. The biochar or the charcoal or the carbon that's in that soil is still there today, all these thousands of years later, and still working. So biochar, again, permanent amendment. The word wood vinegar, the term wood vinegar is a co-product of the biochar making process. It's liquid smoke. And we're using a wood vinegar made from bamboo, so we call it bamboo vinegar. This is amazing stuff. Wood vinegars, or bamboo vinegar in particular, are as important as biochar. Those of you that have not looked into this, I recommend it highly. On our website, blueskybiochar.com, on the video page, the second video down is Biochar 101 Bamboo Vinegar, and it'll explain all the uses. Again, lots of different uses, both in our garden and health and beauty and many other aspects of our society that we can use wood vinegars in. They're fantastic. They've been very popular in Asia for many, many centuries. Wood vinegars are fairly new to the United States. I've been pioneering it for about 8 or 9 years, and it's really starting to take hold. One day, biochar and bamboo vinegar will be common practice in gardens, farming, and horticulture, and all industries related. So check up on this bamboo vinegar, really incredible stuff. Now this happens to be, I just wanted to go back for a second, I didn't show this earlier. This is our compost that we make in our backyard here. We have a massive composting setup, and it has about 15% biochar in it. Now we put a lot of ingredients into our compost. We put in biochar, our food waste, our yard waste. We do shredded paper, we do manures, we do rock dust, we do bokashi. Just about almost 20 different ingredients in our composting, which means that the more diverse inputs into your compost, the more you get out of your compost and the more your soil gets out of your compost, and so forth down the line. I also use mycorrhizae a lot to build up our fungal qualities, and I only mention that because this is the one that I use, and this particular mycorrhizae has biochar in it, small trace amounts of it, to help the mycorrhizae when they come out of dormancy to have a little place to immediately habitat in. So the other couple of things that I want to talk about before we go on to the backyard is, here's a piece of biochar. This is made from a wood from one of the trees out in the yard. Now this little piece of biochar has so much surface area. What do I mean by surface area? Well, in the teeny pore structure, when you look under a microscope, there's all these little pores, and inside each pore there's a surface. And if we measure the surface area of this particular piece of biochar here, it'd be bigger than a basketball court and probably several basketball courts in size. So that surface area is what helps us hold water, nutrients, and microbiology. That's why biochar is so unique as opposed to using lava or pumice in your garden in the soil mix. Nothing works like biochar. Biochar also can replace peat, vermiculite, perlite, and other things which have very high carbon footprint, and it works much better and it lasts centuries. I have 3 books I want to recommend to you. The first one is called The Biochar Revolution by Dr. Paul Taylor. Paul's a dear friend of mine. This book is a few years old, but it's still quite relevant. What's special about this book? 18 different contributors contributing all of their experiences to biochar. This is available on our website. The next book, which is probably one of the most inspiring books I've read in many years, is this one. It's called Burn, Using Fire to Cool the Earth, by 2 colleagues and friends, Albert Bates and Kathleen Draper. This book either in a hardcover or an audio, will absolutely blow you away. It is so amazing. It's very extensive in all the things about biochar and other related things for all its possible uses. The third book, which is absolutely astounding, and many of you probably already have this book. If you don't, get this book. It's Matt Powers' Regenerative Soil, the Science and Solutions. I did contribute to this book on the biochar section. Many wonderful, amazing human beings on this planet contributed to this book, so I highly recommend it, getting this book from Matt Powers. So at this point, I want to just say a few things that I have a pretty big sized garden in the back. We're not going to get to see it all today, but we'll get to see some of it. I live in Thousand Oaks, California. And in 2013, the city of Thousand Oaks was the first city in the nation to officially adopt biochar. Since that point in 2013, we have planted in excess of 6,000 trees using biochar. Not a single tree died, even during the drought. And many of these trees are not irrigated. They live just off of natural rainfall. One tree did die, a car ran it over. Other than that, tremendous success in the program. And a few years ago, the city wrote into law that any time on municipal property that any landscaping was being changed or adjusted or added, biochar had to be added by law in this city. So we got a city that took it seriously. We're hoping that other cities and municipalities follow that same rule. So at this point, I think we're going to take a walk outside and we're going to go over to our composting setup. We're going to take a look at how we do our composting, and it's a very unique system. And we'll talk about how you can do composting, because if you're not composting now, you need to be. Compost is not only good for your soil for the nutrient and biology effects that it has, but what is compost ultimately become? Your next generation of soil. That's how nature does it. When the charcoal falls down to the ground and leaves fall on top, it's composting that char over decades of time and creating the next generation of soil. So composting is vital to any garden. It's the lifeblood of your garden. Here we are at what we call our composting barn. It's a rather large setup, probably larger than most people do, and it's very unique in its features. So let's step inside here. So here we are inside the composting barn, and as you can see, it's farm screen all the way around, floors, walls, and ceilings to keep critters out of it. And the pile is 10 feet long, 6 feet wide, and anywhere from 2 to 5 feet tall in order to accommodate quite a bit of several yards of biochar at a time. Right now, there's probably about 4 to 5 yards in here at minimum, probably more. And we have about approximately 20 different ingredients that we put into our composting. We have our food waste, our yard waste, we have manures, we have biochar, we have bokashi, we have rock dust, we have shredded paper. Oh, just a wide array, frass, insect bug bodies, you name it, whatever is an organic material that can be composted is in here. So we cover it with straw, but as we look down here, we can see there's beautiful, rich, decomposing materials. And look at that grub worm in there. We collect these grub worms and feed them to the birds and friends who have chickens. They just love them. This is the grub of the fig beetle, and there's quite a few of them in there, usually several hundred at a time. Now, every time we add material to our composting, we always put a blanket of biochar on top and then blanket that straw on top of that. The purpose of having a blanket of biochar on top as well as biochar mixed in is that as greenhouse gases are coming out of the pile, they're being sequestered by that biochar. So this compost pile is extremely clean to the atmosphere, putting out virtually almost no or hardly any CO2, NOx, or methane that normally is produced by decomposition and composting. This is also an aerated system. We do not have to turn this compost, because as you can see on the ground here, we have this large blower and this special timer here, and every hour that comes on, and then there's a giant pipe that goes underground, and underneath the pile is a giant maze of 4-inch piping with holes in it, so it puts air up through it to keep it aerobic at all times. So there's no need to turn. The advantage of not having to turn it is when you turn your compost pile, you tend to disrupt microbiology, particularly the mycorrhizae fungal and other fungal qualities of your compost. And we want to do that as minimally as possible. Plus, when you turn it, you're releasing more greenhouse gases. So by having this aerated system, there's no need to do the turning. Now, we're very busy here at this property in my backyard. We have a lot of projects going on. So we want to be able to not have to spend time turning it, and also adding water to our compost. We have this little system that I built. It's called our rain system, and it's these pipes on the ceiling here, and there's little holes in them, and any second now it's going to come on. There it is. And it evenly distributes, just like rainfall, all over the compost pile when moisture is needed for our compost. We monitor the temperature and humidity or moisture content of the compost on a fairly regular basis. And as you can see, it's doing a beautiful job evenly all over the entire area of the compost. We've had this set up for quite a few years, and we make some pretty amazing compost in this setup right here. So when we harvest our compost, since we have so much in there, using just a screen tray is not really feasible because it takes much too long a period of time to do. That's where we have this machine. It's called the shaker machine. And it was my friend Brian Spangle from Organic Solutions state-of-the-art worm farm. And it was sitting in the back. It's something he hadn't used in years. And I said to him one day, I said, "Brian, what do you do with that old machine?" He goes, "I don't know, Michael. You want to buy it?" I said, "No, but I'll store it for you." It's been here 6 or 7 years, and he's basically just given it to us. So we throw the composting material on top here. The whole thing shakes, makes a loud noise, and all of the finished compost goes down through the screens into the trays below where we harvest it. And then all of the bigger materials and undecomposed stuff goes off on the end and goes back into the composting barn to keep processing it. We even put mussel shells, clam shells, crab bodies, bones. Like every Thanksgiving, we throw the turkey carcass and bury it in there. And then those bones, when they get all eaten up by all the biology and they're all the surface material on the bones, we harvest them out of here and we put the bones into a separate bin, and then we make bone char out of them. So everything on this property is reused, repurposed, recycled. The green bins that you use for your yard waste that most people have, we haven't used them in 9 years. They're sitting in the back there. We keep all of our organic material to either make compost, make mulch, or the woody material we make biochar from it, from the trees that when we do trimmings. So over here is the finished product. As you can see here, this is pretty amazing compost. Very complex. This is not a product that you can buy in a store. We don't actually sell it because we need all the compost we can get for this property. We compost every 2 to 3 months, so we're constantly putting compost out. We're top applying it, and it's got about 15 to 20% biochar in there. The range of biochar in your composting goes between 5 and 20%. You don't really need to go beyond 20% because you're not going to get that much more advantage out of it, but 15 to 20% is what we call our sweet spot. So you can see the little flecks of biochar within the compost there. There generally are worms in here. We get a lot of worms because we not only feed worms, put worms in there, but they proliferate in there themselves. So that's our finished compost product. So this is what we call our fortress. It's an enclosed raised bed garden to keep critters out. We've noticed that some of the areas that we grow outside, the critters tend to eat our fruit and vegetables. Everything that's very sensitive that gets eaten by critters, we put inside this little fortress here. So let's just go ahead and step inside. Right now we have our winter garden in here. And you can see our beets and celery and collard greens and cabbage. And back there we've got mustard greens, we've got kale, we've got broccoli, parsley, cilantro, a whole array of different winter vegetables. We've got onions over here in this corner here. And this was built several years back. It goes several feet down, this farm screen or hardware cloth covering the floor, walls, ceiling, everywhere, so no critters can get in here because the Rabbits, squirrels, birds, and rats just love to eat the good things that we want to eat for ourselves. That's why we created this fortress here. So to sum things up for our session today, I'd like to share a few things about the state of the biochar industry today. 16 years ago when I started doing biochar and research and using biochar, making biochar, and eventually selling biochar, the industry was pretty small and biochar was very, very costly. Today, biochar prices have come down dramatically. It is feasible for large farms, both tree farms and agricultural farms and horticultural operations, to be able to use biochar at a cost-effective rate today. We sell truckloads of biochar every month to various companies, so our business has grown quite a bit over the years. The biochar community is a very diverse community. There are big companies getting into it. Worldwide, biochar production is rising at a rapid rate, and more people today are getting into biochar than I've ever seen before since I've started in this. So it's a very exciting time to be into biochar. And sometimes people ask me, well, when should I put biochar into the ground? Is it seasonal? Do I put it in the winter, in the summer, in the spring, in the fall? The truth of the matter is, get biochar into the ground as soon as you can. The sooner you get it in there, the sooner it starts working. It works constantly, 24/7. It'll be there for centuries. So there is no seasonal time to put biochar into the ground. Whenever it is that you're working on your soil, get it into there as much as possible. Now, biochar is not a top application necessarily because it needs to be in the root zone. The roots want to attach to it. So you want to get it into the root zone. Now, we follow non-tilling methods. However, when I'm building a new area, either in the ground or in a raised bed or potted plants, I will till once to get the amendments in there, and then after that point, I will never till again. I'll use cover crops, I'll use other methods to keep my soil really going well. Keep that living soil alive and continually growing. Once again, I want to thank my dear friend Matt Powers for inviting me to participate in this event. Our future is our future. Biochar is a key component in that future. Now, there's many aspects of permaculture and regenerative agriculture and horticulture and farming that will benefit from the use of biochar. And when we look at biochar, we look at something that is so unique that nature created and that humans adopted thousands of years ago. Now, obviously, we make biochar today in a much cleaner, much more efficient way than nature does. So we've advanced the technique by using biomimicry. We're mimicking nature all the way across the board. That means that basically we're doing what nature would be doing, except accelerating it in a natural way and utilizing it and making it more efficient and making it more cost-effective for everyone to be able to use. So thank you so much. If you're ever in the Thousand Oaks area in Southern California and you want to come see our garden, it's quite extensive. We're not going to get to see it all today, but I invite you to call me, contact me, and set up a time and we'll give you a tour of the garden. We have people coming through every week on a regular basis for several years now, and I just love sharing what we're doing here. We are an educational-based company. Everything about what we do is about education first. And then we also do provide all of the necessary ingredients, extremely high quality products to help you create your own living soil and take your garden to the next level. Thank you so very much.